We've spent the last few days talking about how to optimize your enterprise. Here's what you had to say about where business and technology are going next.
I think in terms of IT trends over the next 10 years, we're definitely going to be continuing to define cloud. What's the difference between cloud and managed services?
In a year from now, we're going to keep hearing about more about big data and applications of that. I think that's going to trickle down from enterprise applications to more of the mid-level companies.
I think we're going to be talking a lot about mobile computing. We've already seen computing shrink down from being luggable, suitcase-sized PCs. Now we're carrying around hip-sized supercomputers.
We'll most likely be talking about storage, because the way things are growing with big data and all the trends that we're seeing with lots and lots of storage that's required.
Now we have the tiered storage where it's tier 1, tier 2, tier 3. I see kind of tier 2 being compressed and kind of going away, whereas now you just have a tier 1 and a tier 3.
The biggest trends will be converged infrastructures and faster storage.
Solid state memory, whether it's flash or P-memory or electron spin or whatever comes next, is going to continue to be a major trend.
Everything the millennials want, pretty much, is what our IT departments need to start delivering.
What do I wish my data center had that it doesn't?
More blade servers. We've got blade servers now, but I can always use more.
I want more storage. We can never get enough storage. We're in the sequencing industry, and storage is our #1 concern.
Something which can manage everything easily at the touch of a button or something, like one console which manages everything.
I don't know, that's a hard question. My data center is actually pretty awesome. Not everyone can say that, but I can.
Our data center is pretty spectacular. We just built a new data center. We actually use a lot of Dell solutions, Compellent, Equalogix, Dell Active Fabric. So there's not a lot in our data center that I would do differently. It's pretty incredible.
I would like to optimize every component of the data center.
Lounge chairs and something a little more comfortable than just a hard floor, because sometimes we're there for hours at a time.
Please welcome Sam Greenblatt, Nariman Teymourian, Mike Klemm, and Jimmy Pike.
Gentlemen, good morning, and thank you for getting up after the party last night and coming to hear this. What we're going to do is going to be unique, because we're going to go through not talking about megatrends, because I leave that for the analysts and the press. We're going to spend a lot of time talking about what we think and how our products are fitting in to the future direction of the data center. The data center is flattening, and we're going to talk a lot about that and the megatrends. We're going to talk about the evolution of computing, big data. Of course, we have to get big data in there. The difference between transactional and relational, what exascale means, and management of this entire environment we're talking about. What's important today is I have 3 esteemed colleagues that are basically what Mr. Jobs, an old friend, used to call A players. What I found when I came to Dell is we have A players and people who look for challenges and put the customer first and then work back to basically figure out what our product roadmap should be. And before I do that, you've heard some of the biggest announcements we've made in a long time in storage. You've heard an amazing announcement in basically our server area, Vertex. And you've heard, you'll have a super session today with Mr. Burns, a good friend, who will talk about what we're doing in networking. But before I start and talk to my colleagues about the things we want to talk about, I want to point out that people have to think, and that's what we're going to be talking about the whole time, in different ways than they've thought about before, because the class of computing has changed so dramatically. And last night I was reading a patent that was written in February 14th, 1893. It's patent 49 12927. And what's important about that patent is it was the Sentinel patent that everybody was clamoring for. It was a horse with an engine in it because they did not want to disrupt the ecosystem of the horse back in the 1890s. And they never dreamt of highways, they never dreamt of motor cars, but they wanted to make sure that there was a patent for putting a combustion or steam engine inside a horse that could actually drive the carriages. That is some of the thinking that we still have. We know our ecosystems, we're comfortable in it, but we're going to see a radical change, and that's what we're going to talk about. And the last thing I want to do, can the people from the networking server group and storage group stand up? These are the guys who brought these products to us that we've announced over the last couple of days. And let's give them a round of applause for basically doing it. You know, I have the easiest job in ESG because what I have is to stand on the shoulders of these giants who are changing the industry. And I want to thank them for that. So why don't we get started? And I get a cushion that says Dell. That's fantastic.
You're the only one who gets it.
Okay, let's start out by talking about the evolution of computing. And we'll talk about trends in technology and computing, but what's the most important thing, and I'm going to start talking to the panel, and this is going to be the same way we talk in Round Rock, in San Jose, Eden Prairie, Nashua, when we are talking about where we should go and what we should be doing. And you'll hear disagreement, and I guarantee you from these guys with me, they'll definitely disagree. And you'll hear some concurrence, and we will play off of each other so you get a good feeling for what Dell's thinking about going forward. Some of the opinions may be ours. Some of the opinions we'll be very careful to tell you what we're thinking from the company. But I'm going to start out by saying 3 controversial statements. And anybody who knows me, that is not unusual. We're going to talk about Amdahl's law, Moore's law, and of course, of everything else, Jimmy's law. And I'm going to start with Jimmy Pike, who's a senior fellow. And Jimmy, why don't you tell us what you think is going on with the evolution of computing?
Well, one thing's for sure, computing as we know it is changing, and a lot of it's driven by cloud. Most of the things that are happening are driven by the mobile environment. Everybody's got 2 or 3. If you're like me, you're one of those geeky guys, you're probably carrying 4 mobile devices with you. And all that's generated new ways of doing things and new ways of doing data. And I think that has probably, in fact, I would argue, there are 10 eras in IT that I've identified. And we're in what I call this is the 10th era, by the way. And it's the era of persistent connectedness. And what it is we're either persistently connected to the web, or we think we are, maybe we're not quite. And that has pervaded everything that we do, the way we live, the way we work. In fact, you and I were talking. I've got a daughter, she's 20 years old, and she can type about 600 words a minute with her thumb. So it's pretty wild to see that. But all that is changing the way computing is done. And as you said, the tiering of computing, where there's computing that has to be done locally and computing that can go all the way back to very large data centers, I think we're going to see a hodgepodge of things happen between the user and those computing.
Oh, absolutely. IDC came out with a report just recently that said 90% of the data being created in the industry is being created on mobile devices. Think about the ramifications for a minute of that. And also think about the ramification of bring your own device when 90% of the data is being done there. But we're going to talk about one more thing, and we'll go in this area with Jimmy and Mike and Nariman. One of the things that's very, very interesting to us is that the concept of von Neumann machines, which are the classical CPU, server, storage, is being totally dismantled in the industry today because we have problems. We can't get dense enough, we can't scale fast enough, And what's even worse is that we basically create inherent bottlenecks in the very architecture that in 1948 was written that we're still using today. And with that, there's a law called Amdahl's law, and I'll have Jimmy explain it, and then I'll have Mike follow right behind him.
Well, Amdahl, in fact, you were there when he wrote this, right?
No, he was in my class. I taught Gene.
He put the hole in the marbles for the abacus?
Yeah. When abacus was invented, Sam was there to see it through.
Ah, got it.
I really do appreciate that now.
Well, you said do it just like we do back in Austin, Round Rock, right?
That's
the only thing
true.
we couldn't do was swear or throw things.
Just don't throw anything.
Okay. So Amdahl's law, it may come as a real surprise to folks, but Amdahl sort of had an idea how this stuff worked. In fact, I saw where Sam said, Gene, why don't you write some of this stuff down? It's pretty good. And so Amdahl's law, what he said was the final performance of your solution will ultimately be determined by the algorithm you choose to implement. And if you're like me, you're kind of, what the crap is that supposed to mean? So what he said was, if everything is working about as good as it can, the only way you can change your performance or materially impact it is to change your programming model. And what you have to do is you have to break your programming model into independent threads, and as many independent threads as you can get. Well, there's a point that doesn't matter anymore. But having these independent threads that can be executed in parallel at the same time, that's really the basis for getting your work done. Now, unfortunately, it's not quite that simple. You have to have this layer of software that's called the dispatch that starts all those threads up. And when the threads finish, you have another layer of software that's called the coalesce that runs out and it picks up the results and gives it an answer that you can use. So in a sense, that's what Amdahl said. Now, the problem is the more threads you get, the bigger or deeper your dispatch and your coalesce layers get. And so you get to a point where you can't add anything anymore. But one thing he did note, and I think we violate this all the time today in the industry, is data at rest should remain at rest. And all we do, if you know how our systems work today, is we move it over here and grind on it a little while. We don't like it being over here, so we move it over here and grind on it a little while over here. And we don't like it being over here, and we have threads that can't get fed and things like that.
And that's a good transition to Mike.
I look at Amdahl's law a little bit differently, is that I look at it as it's basically coming out and saying that the slowest part of your system is going to basically dictate how fast it can go.
Exactly.
And it is basically, if you read a more layman's description of it, it is the latency and how long it is that if I slow down, if I speed up 20 things and my one of them is the longest thing, that is going to dictate the entire process. So going out and looking at Amdahl's law and coming in and saying, okay, I need to make everything faster, and I need to kind of basically take the latency and take out how long it takes to do a unit of work, is I need to go do that. And in order to do that, I need to essentially speed up my compute. I need to speed up how fast I can access my data. So by doing that, if I go on and look at it again, is that the slowest part of any compute system is the storage. And what I need to do is I need to come in and I need to get that data so it is closer to where the compute is.
Well, one of the things that we're finding and we're talking about all the time, is Mike hit on it, is latency. We are very concerned about latency, and we're working on all kinds of fabrics and technology inside the box and inside storage, and our RNA product was there to start to remove latency. Well, why that's so incredibly important is if you try to fix one latency, you're going to break something else. And if you look at the models today, if you take it to a von Neumann model, if you tinker and speed up a storage or a processor or anything else, that's like putting a Ferrari on a dirt road. If the road isn't tuned for a Ferrari, you might as well be driving a Chevy.
Actually, you could start with an F-250. It works pretty good.
The 250?
Well, one of the things that we are seeing is the distribution and virtualization was a natural outcome of the breaking apart of the von Neumann machine. And my friend to my left, Mr. Nariman, will discuss one of the things we're doing to optimize virtualization within the core infrastructure of the new evolution of computing.
Right, so for us, I think the most important thing is to ensure that we have this concept of active scale, this notion that Marius talked about, and the importance of converged infrastructure that is bringing together a number of different components. For us, virtualization has given us the opportunity to look at the amount of stuff that we can do significantly more than we did before, especially in a compute layer. And with our converged infrastructure platform, I think what we see the trend coming is the ability for customers to want to do a lot more with what they had before. So for us, to manage the virtualization layer, the concept from my perspective is to ensure that you have the most optimal way that your hardware and your applications are combined together to deliver a very optimized virtualization model. So, if on our converged infrastructure model, you can scale out, you can scale down, you can ramp up as many VMs as you need to, you can bring those number of VMs down and manage them in a much more focused environment. But what it does do, and I think this is, as you guys were talking about, Amdahl, and I wasn't, alive when Gene was talking to Sam, but it was clear to me that
that's a good point. We should give attributes to the pioneers of the computer industry.
That's exactly right.
People like Amdahl, von Neumann,
Sam Greenblatt.
Sam Greenblatt, yeah.
That's right. That's exactly right.
The ones
I
who were
would
here
love
when
to
very
be in
early
that company.
That's exactly.
I'll tell you, I would love that.
Yeah, but also remember, when you have to look at it from the customer's perspective, right? What does all of this technology mean? The customer wants to have a set of services available to their end user. Virtualization is a way to get there. Delivering virtualized capabilities, both on the networking side, on the storage side, as well as on the compute side, is a critical factor as a next stage of evolution. But you're not going into sensor technology, which virtualization is going to significantly improve. You have smart homes, you have smart cars, you have smartphones. You're going to have smart clothing next. So virtualization is a step in that direction. It's a trend. It's an evolution of computing as we see it today, and we have a point of view on it.
We have measurements of how many servers we ship with virtualization. Most of our customers were last doing 20 virtual machines. The average is now up to 50. We expect it to go to 100. So virtualization is going to be important. And what Nariman's looking at is how to go on. So let's go to the next topic, which is going to be probably the most controversial, because everybody agrees we got to change the compute model, and that's big data. One thing engineers and all of us up here have in common, we think our job's hard and everybody's job is easy.
Except for yours, we're pretty sure.
Mine's very easy.
Yeah.
For example, we all think that we could do marketing and finance better than anybody else.
Certainly,
and
sales.
they couldn't do our jobs. So literally,
we just made friends.
When we look at our big data,
Mike said that.
A lot of friends.
When we look at our big data area, the thing that's really incredible to us when we look at it is, I'm going to give you some statistics where the data is coming from, and most of you in this room, and especially Mike, worry about this all the time. There are, as of January 1st, 100 billion sensors in the world emitting data. Somebody's got to get that data, manage it, and use it, and we'll talk about that in a minute. There are 4 billion internet users. There are more internet users in some of the developing country than those people who have power and water, which is incredible. And 90% of that is video and pictures. We think big data, and we're going to talk about it in a second, is really a very, almost as hyped as the word cloud that we heard quite a bit. 20% of our customers that we surveyed are using big data for advanced analytics that everybody's talking about. 80% are using it for extending their data warehouse and using access methods to get the data locked up in their data warehouses. So the concept of big data may be coming, but it's not the topic that is of top of mind. It may be the top story in American Magazine when you fly, but it's not the story that we got to worry about. We got to be able to take the data, because data is going to be critical to the context that it's used, not to the context that it's stored. And I'll start with Mike on this one.
So I'll admit I'm not a big believer in big data. I think it's there. I think it's a fancy term, but it's essentially, it's the same thing we've been solving all along.
So, Sam, when you said we say something's controversial, did you mean controversial or just plain wrong?
He is right.
You got to explain.
It's there. It's something that we have. I think you have some big data here.
This is my Geekalator. Okay.
Yeah.
That's 2 dual socket Xeon servers, 2 independent servers, the same servers we put in our hyperscale machines. 2 disk drives down here, 2 disk drives down here, 4 terabytes each, 16 terabytes of storage in my little calculator here. That's enough storage to put all the literature in the Library of Congress. Now, what is this about big data not existing? Help me.
Well, it's there, and I think you should try to go show that to the president later. I hear he's in town. So.
Well, especially if you open it up, it says ARM on it.
Yeah,
like
it says ARM in there. You know, it's something that somebody might want to talk to you about.
You should take it to the Fairmont Hotel, see what the Secret Service thinks of it.
If you're going to take something through security, this little calculator is got some other things in it. It's got 4 Raspberry Pis. Actually, it's only got 3 ARM-based Raspberry Pis, because Sam was moving to Austin and he and his wife were in a hotel room, and I was afraid he wouldn't have anything to do, so I gave him one so he could play with it. I took it out here.
He almost got me divorced over it.
So there are 4 Raspberry Pis, or actually 3 in this box, 2 Xeon servers, and what I so cleverly did was I labeled them. ARM 0, 1, 2, 3, ARM 0, 1, 2, 3. If you're going to take something through security where
at the airport,
the idea of the fellow, by the way, if you're dealing with an individual whose title is Special Risk Assessor.
That's not a good day for you, is it, Jimmy?
So the idea, the first question, he said, ARM, what are you arming? And I said, wait, that's not what it is. About the only thing I could have done worse is put the word trigger right there. But this is a fully functional calculator. 2 dual socket Xeon servers with 16 gigabytes of storage each and 8 terabytes of storage each. And it's all interconnected, and there are 4 of these Raspberry Pi ARM servers in it. And the reason I made this is because I was carrying a lot of stuff around with me, and I wanted to simplify my life. And wow, maybe that didn't work out so good. Anyway, the idea of big storage and well, maybe we don't have big data. We sure got big storage.
And we have big storage. I think we have big data sets too. I really think that, you know, we're going out and we're taking data sets together and we're putting them together. We're going out and we're looking at the relationship of information. We're trying to go out and figure something out that we couldn't figure out before. And it's the next evolution of looking at what we have and saying, I can do something additional with that. As before we were basically going through the motions, we were using compute to essentially go and take care of the transactions of our lives and to record everything. And now we have to go out and essentially, we want to learn information from this. Is that one of the things that I always do, you know, you go out and you go on the internet, and I always look at what the ads are. And not necessarily that I look at the ad because, you know, I really like advertising. It's that I want to know how that ad got there. And that ad is essentially, it's going through all the information that I have compiled and what they've recorded on me, and then all of my friends and people like me, is that I think that that has been done, and and what we've done is we take all that data, and it's a big compute problem that you have to do, and you look at that is that there's the immense amount of data that we're generating, plus there's big data in terms of trying to put everything together to try to come up with a recommendation for you.
Let's take a survey. How many of you folks have ever been on the web and you see a ad in the right column over there where they like to put right columns, and it was something you had looked at the night before, just had to kind of match up with it? How many of y'all have seen that? Yeah. That's kind of scary.
Yes, it is.
So the context pieces of it.
But I think this is important, but let me ask this from a customer perspective. Okay, so there's big data, there's a huge amount of data. There's a place that Jimmy has in his briefcase to store it. Question really is, what are we doing with the data?
What
is the answer
got
to that?
the answer to it. 45% of the people are taking their data warehousing and being able to search it. 10% are using it for product placements on the web. 15% are using it for security by 3-letter agencies, like we found out in the press today with the Verizon phone numbers. 5% are being used by credit agencies to check your credit scores going through it, and 5% is miscellaneous. And if I knew what the miscellaneous is, we'd all be in good shape.
Yeah. But also remember this, that behind what Sam just said is the whole notion of being able to figure out how to use this data. You have to have the analytics behind it. Most of this data is in flat files, it is unstructured data. So the real value of big data is the way you analyze it, is the way you ask the right question. They talk about real-time data, for example. Imagine, to me, real-time data, it's like, okay, if I look at the football game's first period, do I think that I can detect what the end result of this game is going to be, what the score is going to be at the end of the fourth quarter? No, it's a specific, snapshot of time. So you need to understand how to ask the right questions to get the right answers in this analytics. And having the massive amount of data, being able to store it somewhere, that's just the beginning. The value of big data has to be in the way you ask the question, you analyze it, you query it, and you deliver that to the marketeers.
And I don't think it's even, I don't think you have to have the analytics as well. I think having the data itself is something that you don't know what the value of that data is today. Is that, you go out and you look, we have customers that, you look at the oil and gas people. They've done surveys many years ago on how they went out. They keep all the data because they find new ways to go and look at it, and then they can generate additional value from that. And you look at what people have done with, medical imaging going online now, is that the ability to store that as you want to look at it in the future is that you don't know what you want to look at right now, is that sometime in the future you may find a use for it as well.
Well, we'll be glad to talk to you about our theories on big data as individuals and corporations, but we call it data analytics. That should tell you what we think of big data. Let's move to the next topic. And by the way, the compellant, basically the dense compellant, is a good place to store all that big data. No commercials, and it'll be a great place to also tier it into cache. Let's talk about transaction versus relational. This is a controversial subject because I'm a baby boomer, since I may be before a baby boomer, according to these guys. And one of the things that we've learned is
Are we going to let him get away with saying that?
He can say it about himself.
They basically, and I keep using they basically, one of the things that we are going to look at is transactional systems are book of record systems, general ledgers, airline systems, banking systems, things like that. When I look at generation X, Y, and Z, and we were talking about this last week in Round Rock, all three categories look at computing like BYOD, bring your own device, being able to go on Facebook and generate data from Facebook. Hopefully you're all generating data on Twitter from here. And actually what you can now do is actually complete transactions on all these social and web-based systems. And we think that is this is all leading up to an area where the flattening of the data center is going to be disaggregated and transactional versus relational. And that's why you saw Vertex, because the closer you get the processor to the data, to the point of action in a relational model, makes your world a lot easier. So I will throw it out to Nariman to start out on this.
Yeah.
Since your daughter tweets all the time.
I know, it's amazing when I look at the amount of data created, but as I was saying before, I think the question is, what is this going to be used for? At a time where you used to have, reports generated for CIOs that said, here's where we're spending our money, and those things are changing. You're getting into a situation where the question has to be asked about where do I need to spend money to get the most amount of customers, and how quickly do I get to those customers? The profitability line in the corporation is going to be determined by the behavior of the customer that you may not even know is going to be your customer in the future.
The beer and diapers.
Exactly, that's exactly right. So you're going to be in a situation where you need to figure this out. And companies who...
Tell that story.
The story is Walmart has discovered that any customer coming into the store after 5 o'clock at night that was buying a diaper, disposable diaper, was also buying beer.
Right.
And they got that through basically not only big data, but analyzing transactional and relational data.
So what they did was they put the beer by the diapers and doubled their beer sales.
Absolutely.
That's right. Yeah. Well, you know, I don't even want to think about the concept of getting drunk and changing your baby's diaper, but that's a different context. But so that's exactly where we're going with that. You know, the notion of how, and you know, with online shopping, when the trend in online shopping is almost doubling every year, you can imagine the kind of stuff that you need to know way before you even begin to think of designing a product, where the customers who you want to reach, who you do not have today, have a certain type of behavior, and that behavior is going to have to go directly into your product development, right? So, you know, the concept of transaction versus relations is going to expand and expand it. And with the, you know, we talked about sensors, we talked about big data, and we talked about the perspective the customer is going to have when all of this stuff is going to come together. And as a vendor, as a product developer, as a, you know, marketeer, you're looking at patterns emerging. You're not looking at transactions. You're looking at much more complex patterns that you have to decipher to better understand how to design a product.
What's interesting is most of you probably don't, you saw the genomics project, the HPC project, where, and it's basically, you couldn't call that a transactional system trying to find genomic matches to pediatric cancer. But one of the things you'll see, Jimmy, what percentage of the hyperscale market do we have right now?
Oh, it's really rather small. It's 55.4%.
Can you be more exact?
Well, we're 20,000 units larger than the rest of all of our competition put together, so I guess you could say we have had some success there.
And when you look at the systems, and you have Drew and Tracy and some of the guys from the server group here, and what you will find is they're changing the compute model for these large customers to deal with relational more than transactional.
This is an interesting thing, and you both kind of hit upon it. About 7 years ago, we went through a paradigm shift that was very subtle, but it was very profound. What happened is almost all the advancements in IT to that time had been around order delivery, booking, financials, ledger creation. And it shifted from the things that are now driving IT are personal information. It is the social networking. It is this fascination we have with telling everybody when we have to go to the bathroom, you know, that kind of stuff. and the idea of security or privacy has sort of vaporized in many ways. In fact, I read a statistic the other day.
There is no privacy.
Over 75% of divorce cases these days have to do with evidence that was found on Facebook. Now, that's kind of an interesting model. So the idea that we have moved from transaction to always being connected is pretty much there.
And that's the relational model. By the way, the relational model generates 5 times the amount of data of the transactional, and it always has to be very quick. And I'll give it to Mike on that one.
Yeah, so, and I look at it, you know, with, you know, you're talking about, you know, basically bring your own device. We're talking about computing being everywhere, and, you know, we're looking at people are all over the planet, is that the one thing that you're really ending up with control in is your infrastructure, is that your data center is the only thing that you essentially can control, is that you have to deal with everything else being on the outside. So we need to be able to better optimize that and go out and deliver that data as quickly as possible to you. You know, so we talked a little bit about this with the data being as close to compute, and I think, you know, early on you were talking that the data should never move. Well, I disagree with that. I really think that there's times where the data should move based on, The fact is that that data is relevant for a certain period of time, but it ages, some of it ages fairly quickly, and it should be moved somewhere else at that point, as you don't necessarily need to keep that in an expensive location.
I agree. I agree there are times where data that needs to move, but I think we sort of are way on the other side of what makes it relevant. Here's the deal. If you take Moore's Law, everybody loves Moore's Law. You know, we've all talked about it. We now have lots of threads per core. Well, you can do that, but you wind up waiting on your threads, right? You can have lots of cores per CPU.
So you move the data closer to the processing.
Lots of processors per server. So you're moving the data into the processor. I would posit that we are almost at the edge of where you can do that. I mean, there may be more things that we can do, but the ability to get more data into, work on it, and get it out, so we're sort of at the limit of that.
Okay, so I actually think, you know, we're probably a little closer, just a little language difference there.
I think that the next evolution is going to be not moving the data where you can do work on it, but moving the work to where the data is. And that's what I think. If that's not what Amdal said, I didn't understand it.
40 seconds.
But we also want to talk about the ownership of data, right? I mean, you know, who's going to own the data? Where's it going to reside? This Internet of Things with data moving to the cloud. The question really is going to be, okay, do we own the data that we generate?
We're going to talk a lot about that in the management section. So why don't we table that for 1 minute? Let's go to the next topic. Exascale. This is my favorite topic. Does anybody know what exascale is? It's 10 to the 21st. And does anybody know what comes after exascale? Just yell it out if you do. Yotta scale. And when Yotta shows up, I'm getting out of here. I guarantee you I'm moving fast. But one of the things we have to do today, while we're building the servers for you for tomorrow, is we got to move to exascale, because exascale will be here by 2015. It'll be here in exascale, will be here in compute power, in an HPC format. It will be here in storage. And just to give you one example so you can put it in context, 1 exabyte is equal to 36,000 years of HD TV. I know my wife could watch 36,000 years of certain episodes, but she'll never hit an exabyte. And by the way, if my wife ever sees this, she's a great person.
How much data can Sam's got a GPS on his cat. He really does. As God is my witness. How many trips to the backyard can you put?
Well, before we came on, I was showing that the cat is sitting right by the pool in the kitchen, and I could see it from here. The reason I have
I thought I was a control freak.
I just moved to Austin. First day the cat gets out, talking to Tom Burns, our networking guy, and I'm going crazy trying to find the cat. So Garmin has one, and so does Qualcomm. I'm not going to tell you which one it is, because I don't want to plug one vendor over the other. But it sends me 860 points of data a day on where my cat is.
And you're using business analytics to understand.
I wrote a business analytics
program. And then he has the data,
program.
exactly. He's got a data warehouse.
You know what? My wife, you just exonerated me. Man, I appreciate this.
That's true.
Can we come up with a GoPro collar for the cat so we can actually watch where he's going?
I don't want to put the video on the cat yet. Yeah. I don't want to see the litter box. So
I'll tell you what I did do though.
I'm going to figure out how to do this.
I put a video camera in the front, and the side, and the back of my house on all the entrance, and I thought this was going to be a clever thing to do. Right? I've got 80 terabytes of deer running through my yard now.
Let's get back to exascale.
Oh, sorry.
Are you going to put a GPS on the deer so you know where they go?
Actually, that might be a good idea.
Okay.
I'll put one on the teenager.
Ooh, that's another story.
If you really look at the servers we have today, and Jimmy hit on it before, Moore's Law has put us up against the wall. It's not doubling every 2 years anymore. It's flattened out significantly. And we have to design the servers that can actually get us to exascale. And the only way you can do it is to basically do almost a form of clustering, which is getting multiple parallel processes going. This is going to be an area that's really great. The problem is you never programmed for this area. You programmed for that old von Neumann machine we started out with in .1. So things are going to change dramatically, and your data is going to get bigger, your processing power is going to get bigger, and by the way, the network latency is going to start to be diminished because we can't move all this through a pipe.
You know, the IPv6, we talked about whether or not it was over-engineered or not. We could potentially have more addresses on IPv6 than there are atoms on the face of the earth.
And it's not enough.
And just imagine the amount of connectivity to the internet that would exist out there. It's mind-boggling.
My wife asked me, she said, "Are you building Skynet?" And I said, "Well, not intentionally." She said, "Well, if you ever think it comes aware, let me know because I'm getting out of here."
No, when I said IPv6 is not enough, it's with the amount of things we have to move around in a network in a computer center. And obviously, everybody knows what IPv6 is. It's just an incredible concept to have that many IP addresses. You can't do ping sweeps anymore. And by the way, 99.5% of people running IPv6 are doing IP4 tunneling because they don't know how to use it, but they're going to have to learn how to use it. And Tom and his team, when you go to see his super session today at 12:30, I believe, I'll announce it at the end, they're building systems, SDN, software-defined everything. It has to be there because multi-point connectivity in the exascale level is important. And moving the processing to the point of occurrence and putting the data in context is creating such a complex area, it's scary. But what we're doing, and we're going to talk about it now, is how do you manage this? And this keeps me up at night, and it keeps...
So you talk about IPv6 and how people are using it. They're not actually using it to their full potential. And we're going to get exascale, but I look at this as it's somewhat of a software problem too. Is that
huge?
It's a software problem, and if we're using IPv6 to do IPv4 tunneling because that's what we know, are we going to end up using exascale to essentially deliver the same compute that we're doing now? Because we can't go in and redo every single application that we've ever done. So we need to keep some of that stuff around, and it's going to be there for a very long time. I think we're going to have
backwards compatibility.
We're going to have some applications that are going to get there, but we're going to have a lot more that are going to be sitting in our current environment, and they're going to be there for a very long time.
Well, virtualization will always be around.
Yes.
The thing I like about virtualization is it takes a large machine and it makes it pretend that it's a small machine. That's really a clever thing. Or you could do it with small machines. That's the other way I suppose you could do it.
Remember once they built the hypervisor inside the chip, the notion of virtualization as we know it today.
Oh God, not that. Don't put anything else in there.
No. That's well, hopefully that won't happen. But the one thing we are looking at, and all the technicians and architects here, is what is the impact to the system? And we have to understand the software-defined, it's glib. I'm not going to say it's glib, but it's very oversimplification to say the word software-defined data center. It's another thing to implement it and get the amount of work that you're going to have to do, and exascale is going to get you there. And before we close out exascale, I want to talk about one thing on exascale. Exascale is critical to basically tackling new problems. The President's Council of Science and Technology has come to the conclusion that our manufacturing systems are almost like the horse I talked about in the beginning. They're slow, they're cumbersome, and they're not scaling. And the recommendation of the Obama PCAST is what it's called, is to start looking at new technologies and programming techniques, and we're very well and in tune with it to go into the exascale environment. because exascale will be here in 2015. Next topic, Nariman, your favorite topic, management. Now we painted all this complexity. We want to make it as simple as the power grid, where you flick the switch and the lights come on.
You know, this concept, I think, is not a new concept. We all thought about, you know, the time where you walk into a room and when you turn on the light come on, and the amount of compute and storage and networking capability will be available in the room in the same way that HVAC is available in the room. You know, you don't have to worry about where it is, you know, how you're going to use it, and it's going to be there for you when it's available. So the question really is, how do you do that, and how do you deliver the concept, the data, you deliver compute, storage, and everything else as a service to the customer, right? I think the customers are looking at the notion of service as a significant you know, differentiator from everybody who's going to be doing that. So you need to find a way to manage all of this. The ability for you to be able to get things done in that fashion is extremely important. You know, you get into a situation where at the end of the day, when the end user in the business is looking at delivering something, they're not going to look at wanting to buy more servers, they're not going to want to buy more storage, more licenses, or expand their network. What they want to be able to do is to ask the IT administrator, which is going to be the IT consultant in the future to the business user, how do I get this thing done? What is the best way to get this service? So the management layers of the future are going to primarily be focusing on a single piece of pane of glass that looks at compute, network, storage, and application and virtualization in a way that clearly becomes parts of a componentized parts of a large system. They're not going to be looking at, you know, what's the port density here and what LUN do I have to provision, you know, how do I get this particular server onboarded. They're going to be looking at a block of compute, a block of information available, and these management solutions are going to have to be absolutely you know, pervasive across all of this. Imagine a world where you have a management solution that you have a single piece of software that basically tells you for you to submit a request to it for a specific set of service, and it automatically in the back end provisions all the pieces that is necessary for you to get that service. The service could be, I want to train 400 of my end users next month for 7 days. That's a single request that goes from the business community through an automated process to be delivered at the back end. And the IT administrator has very little to do with the components that are there to be able to put it together.
Let me amplify your point. Can you bring up the whiteboard for a minute? What you see is, and I can't see it behind me, but what we're basically talking about, computing following the laws of nature, synaptic, and all that. Your hypothalamus does a good job of controlling your body.
And you don't know it.
And you have no idea, and it's transparent. One of the things that we believe is these will all be compute nodes, hopefully Vertex nodes or other nodes that are there. And the control is exactly what you're talking about. And by the way, storage is embedded in every one of these nodes because we're moving the compute to the storage. This is the new world that we're basically planning towards. And if you don't think that's a complicated world, you're wrong. But you shouldn't have to deal with the complexity. We build at Dell from the user down to the issue. We don't build technology like this to go up and create a search for solutions.
And I think it goes even further. Is that, you know, that's a static picture that we have there, but it's always changing. It's dynamic. You're coming in and you're adding new hardware resources.
Get rid of the,
you're adding new network connections to your network. So it's always physically changing. But your workload and what you're actually doing, you don't want to care about that. Is that you have an application, you want it to continue to run, you essentially want something to be able to dynamically grow on the fly and deliver that without thinking about what the hardware is underneath it, and delivering and essentially saying, are we going to monitor the physical components of the network separately than the software components, and look at what the demand is on the physical infrastructure and be able to expand and contract that dynamically without changing our application?
So let me get this right. To make big data make sense, we have to add context to it, which is going to increase the size of big data, right? Wait, okay. For computing to be where it needs to be pervasive, we're going to have to throw it all over the place instead of have it all centralized in a data center. And to manage it, we're going to have this very complex template, you might call, that lays over the top of it and manage it. You guys ever heard about Occam's razor? The simplest example usually is.
I live it every
day. We've probably terrified half of the people out here who have done
They're not listening. They've been taking a nap for the last 30 minutes.
Only when Sam's talking. So, what are we going to do to make it easy? What are we going to do to...
Wait, Jimmy, stop. Explain Occam's razor.
All things being equal, the simplest answer is the best.
Is always the right answer.
Yeah, so it's like green, right? We should be responsible citizens of the environment. We should do the best to make our servers and our environment as power effective as it can. In fact, that's one of the things we focused on. Dell has the most efficient data centers in the world. To be a geeky, really geek for a second, at eBay, the modules that we've installed on the top of their data center, that's a different story. The top of the data centers, the power utilization effectiveness is 1.025 or 0.026. That means that only 2 to 3% of the power is being used to cool it. That's about as green as you can get. But the real green is the green that you can wad up and put it in your wallet. And that's what we have to be responsible. How are we going to make this simpler and less expensive? Because if relational computing does happen, which I believe it's going to happen,
it's absolutely happening.
The management of it and all the implications of it, and oh my God, what if it goes away? Oh, in fact, my daughter has this, it's kind of like where you have an amputated arm and there's this phantom feeling that you still have that limb. I think when she lays her cell phone down, she still has that feeling that it's there in her pocket. What if it goes away? If we become so dependent on it, how are we going to make it reliable? How are we going to make it reliable?
Secure.
Secure. Oh goodness. What is that? Secure?
Secure. We didn't go over a lot of security.
Go talk to the Sonic Work guys and the...
It's 100% pervasive.
But haven't we been going down this road the entire time? Yep. I mean, we are at the point now where our systems are far more complex. I would argue that anybody's PC, my phone right now is far more complex than the PC I had 10 years ago.
That's
and it works a lot better. We've taken
I don't know if you've heard, but
complexity.
a PC's dead. We only sold 350 million last year.
Hey, Jimmy, no.
No, the point is, though, there is this, I would say, this mantra in the industry that the PC is dead. And it was all kind of predicated by the transition to tablets and cell phones, right? Well, we're dual core processors in cell phones and tablets now, 4 core processors coming on the horizon, 8 core processors are actually the demand for the folks that are creating these devices. So the idea that your computing was going somewhere else apparently isn't going to happen. So instead of personal computing going away, it's just changed. And the change has been there's lots more of it, and it's a lot more pervasive, and we better create an environment that makes this work. And feel free to jump in here anytime you like.
No, I think...
We're running out of time, but and I just got the blinking light. But before we finish, and I really want to finish this, we can finish it with everybody anytime they want. By the way, you can email us, and we'll be glad to respond to you and tell you thoughts.
Feel free to email to sam_Greenblatt.
That's right. Thank you, Jimmy. But the one thing I want to tell you is that's why active infrastructure is incredible. A flexible infrastructure that basically mimics the synaptic network I built up there. We're not there yet, but we're moving towards it. So what I want to do is thank my panelists. This was a very good discussion. We didn't even notice you were out there because if this was in Round Rock, it would be a lot more heated, a lot of different languages. But we want to tell you that we wanted you to see what we're thinking about. So I want to thank you guys. And I want to thank all the technologists and leaders from Dell in the audience. So let me go through housekeeping. If you can go to the next slide. We want you to go to the hands-on labs. You can see a lot of what we have. We want you to give us feedback. let me tell you, as we said, customer down, you tell us what's right, what's wrong. We want you to tell us that so we can handle it. Today at 10 a.m., you will see some rock stars in the network world at the super session, and I would call it a super rock session. And also the Solution Expo is always open, so you can visit not only our people, but our sponsors, and you can win an XPS 10, which is important. So, in conclusion, I get the privilege, if you can go to the next slide. Look, Jimmy and I were put in charge of the location for next year's DEF.
Hotel 6.
And this is the best hotel. By the way, they do have plumbing, so you will all enjoy it.
Is there internet?
But Marius,
they got one in the office.
Marius has final say, and he optimized it. Remember the theory, optimized. He put us in this hotel. Jimmy and I are a little bit disappointed. And so we're save the date. Next year, we're not up against Tech Ed. We're not up against other conferences. It's in Miami, Florida. We want to see everybody there. And by the way, this should not be the end of our dialogue. Please email us. Please call us, talk to us. Nothing is more important than customer feedback to our success. Thank you very much.
Thank you.
Right. We're gonna groove tonight. Let this groove get you to move and sound like alright, alright. Let this groove sit in your shoes and stand up alright, alright. Let me tell you what you can do with my love, alright. Let you know, girl, you're looking good, you're out of sight. Alright, just groove yourself. Take a line like a 747 and lose yourself in the clouds, in the sky, in heaven. Yeah. Let this groove get you to move and sound like alright, alright. Let this groove sit in your shoes and stand up. Alright, alright. Let me tell you what you can do with my love. Alright. Gotta let you know, girl, you're looking good, you're out of sight. Alright. Just tell the DJ to play your favorite tune, and you know it's okay. What you found is happening now. Yeah. Let this groove get you to move and sound like alright, alright. Yeah. Let this groove sit in your shoes and stand up. Alright, alright. Let this groove get you to move and sound like alright, alright. Let this groove sit in your shoes and stand up. Alright, alright. You find peace of mind on the floor. Take a little time, come with me, take a seat, take a little time. I'll be there after a while if you want my love. We can boogie on down, down, boogie on down, down, boogie on down, down, boogie on down, on down. That's cool tonight. Share the slice of life, and baby, slice it right. to